Hey everyone, so in this video we're going to take a quick look at a question that was asked for a video I posted a couple weeks ago. I demonstrated how using the all-in-one Sprite shader, which is available in the Unity store, how to use that to simplify movement for an endless runner. Because typically with an endless runner, you're constantly spawning new chunks of land and deleting old chunks of land, but by using the texture scroll, you can make objects look like they're moving when in fact they're not. So the question is, since nothing is actually moving, how do you handle obstacles and collectibles? And the bottom line is those would need to move. So if I was to run this right now, okay, these objects are not moving, the camera is not moving. This is a texture scroll. Here are the objects that are spawning. And for the most part, they look pretty good. They don't look like they're slip sliding away, so they look like they're in a static position. Although there is a little bit of jitter, I think that clears up once this runs as an executable. There's also a couple other things you can do. So this is what was being asked of me, is how do you handle these? Okay. So the camera's right here, and it's facing through the trench along the z-axis. So you're going to have objects being instantiated, spawned just beyond the camera's view. They're going to have a rigid body, and they're going to have a velocity along the z-axis, and it's going to be a negative value. That way it travels towards the camera. So let's see how we're going to do this. You need two scripts. You need a script attached to the individual prefabs, so the obstacles and collectibles. You need a script attached to them to move them, and then you need a script to choose which ones spawn. So let's look at a couple of the prefabs. So here's the fence, and the commonality between these, or the common denominators, is that they have a rigid body, and we shut off gravity. That way we can add velocity. They have the script that applies the velocity, and they have a box collider. This is in case we do a follow-up to this video. If you want to check for collision detection, I already have a separate endless runner tutorial that handles collision detection. The only thing that's different about this is that the environment itself is not moving. So you could easily take that coding and apply it to this. But if you want, I could do one more video. So we've added a rigid body, the script, and a box collider. So we'll look at a couple more. So here's a treasure chest. So this would give you gold, coin, whatever. Again, box collider, rigid body, script. Here's a crate or a box collider, rigid body, script, and again, gravity is shut off. There's also a rock, but we already reviewed the other ones. Okay, so they all have this script attached to them, and it's just one line of code. So in the start section, get component rigid body. As we said, we just added a rigid body. Now we're going to make a modification to it. We're going to add velocity equals new vector 3, 0, 0, negative 5.1. So generally speaking, in an endless runner, objects do not change lanes. Your player changes lanes, but typically objects don't. Nothing against it. It would just make the game really tough. So generally, you're not going to have any movement along the x-axis. Every object spawns in its lane and stays in its lane. Why? Typically, things don't move up and down. Again, you want your player to know, do they roll under it? Do they jump over it? Kind of hard to do if the thing's moving up and down. Okay, maybe you'd have something moving up and down just purely for visual effects, but that can be a little bit distracting. So generally speaking, you're not going to have any movement along the X or Y axis. You don't want things changing lanes, and you don't want things moving up and down. But you do want there to be movement towards the camera, so along the z-axis in this case, and it's negative, so it's moving from a positive number to a lower number. Now, where did I get this 5.1? This is purely, I don't want to say guesswork, but it's trial and error, because you see, as we said, there's no object movement here. It's a texture scroll. So if you look at that texture scroll, the speed is 1. Well, I'm not one of the engineers who made this, so I don't know what that 1 translates into. I know it gave me the speed that I wanted, but is it 1 scroll per second? Don't know. So what I'm saying is trying to match this to velocity will be a little bit of trial and error. That's all I'm getting at. So that's what I got with that the negative 5.1f seems to make things look like they are staying in place. Now, if you want things to be moving faster or slower, like say it's a car or a bicycle that's driving towards you or away from you, then obviously it would need to either scroll faster or slower. But if you want something to look like it's in a fixed position, then you would want it to match the speed of the texture scroll. So that's all the script that is attached to the prefabs, just giving it velocity. If you make this a full game, you might have to add a little bit more, but for this demonstration, that's all that I'm using. Separately, we have a GM object, and this is meant to hold the script to do the spawning. So let's go ahead and look at that. So what do we got? Still fairly simple. We've got three variables. So public, transform. Public makes it accessible in the inspector. Transform, we just want to be able to access where this is being positioned in its rotation. So we're doing a public transform. You could do public game object, but then you have to drill down to transform, and it makes it a little bit messier. The square brackets turn this into an array. So rather than having one value, this is going to have multiple values. Each value is going to be a different object. So again, an obstacle or a collectible. So public to make it accessible in the inspector, transform because we're going to be looking at position and rotation. The brackets turn it into an array, and this is the name of the array because since it's both obstacles and collectibles, I just called it all items. You can call it whatever you want. The name is irrelevant. You just have to make sure you're using the right name consistently. Private int which item. This has to be an int because which item determines which position you're going to select, because when you look at the array, each object has its own position and it starts at the 0 position. So position 0, position 1, position 2. So you want to know which position. So this has to be an int. If it's a float, it wouldn't make any sense because there's no such thing as a 0.5 position or a 0.7 position in the array. It's 0, 1, 2, 3, so on and so forth. Private int x position. So there are going to be 3 lanes. Typically, that's what you have in an as runner. So -5, 0, +5. So we're going to have an int rather than a float because even though positions are floats, I'll explain why we need an int in a minute. So that's it for variables to make this work. In the start section, we say start coroutine spawn timer. So that's where the bulk of the activity is going on, is the spawn timer. So we come down here to IEnumerator spawn timer. So yield return new, wait for seconds 3. As I always say, I'm not going to explain the yield return new. Just know that as a whole, the net result is that you're going to wait a period of time measured in seconds before everything after this occurs. So wait for 3 seconds. Okay. This is basically setting up your rows. So we already talked about the lanes are -5, 0, and 5. This is setting up your rows. So horizontally, things will spawn every 3 seconds. You might decide that's too long. You might want every 2 seconds, or you might want it to be more of a delay. It's purely game balance because how quickly can your character change between lanes? Can they do it in half a second? Do they do it in a full second? So this is purely game balance. There's nothing inherently right about this. You just want to make sure that when your objects are spawning, your character always has a path, because there's nothing worse than making a game impossible. So even though this is heavily relying on randomization, you need to allow that randomization does not make for an impossible situation. Which item? Random.range 0, 4. So for ints, this is inclusive, this is not, which means the results are 0, 1, 2, and 3. Again, we have a total of 4 objects, so that's why we're only doing. And again, since the 4 is not inclusive, that means we'll never get 4. We'll get 0, 1, 2, and 3, and those are the positions. Those are corresponding to the positions in the array. X position equals random.range -1, 2 times 5. So again, because it's an int, it is doing increments of 1, so it can choose -1, 0, and 1, because again, the 2 is not included. But, as we said, our positions are -5, 0, and 5. So what do? Well, we just multiply by 5. So if the result is -1, it becomes -5. If the result is 0, it stays as 0. And if the result is 1, it becomes +5. So that way we can have the simple random range and then modify it to match the position on the screen. This is only because of how I set this up. If you zoom your camera in really close, you might have lanes of -1, 0, and 1, and then you don't have to do this calculation. If you zoom your camera way out, you might have to make it be bigger. Maybe your lanes are -10, 0, and +10, and then you have to multiply by 10. So again, this is custom made for my situation. You might have to tweak it for yours depending on what yours look like, but at least you understand the functionality. Essentially, you're choosing, is it left, middle, or right lane, and then you're adjusting that number to match the actual position that you want something to spawn in. Okay, so instantiate. As we've said before, instantiate has 3 arguments. What is instantiated? Where it's instantiated in the rotation of what's being instantiated. This looks a little bit messy, so we'll break it down. Here's the first argument, and it ends with a comma. Commas separate the arguments. All items, bracket, which item. So this is saying which position within this array, which we'll look at in just a minute. So it can be 0 through 4, because again, which item, which item. I like that feature of Visual Studio's that if you select a variable, it'll show you all the instances of it. So all items position 0, 1, 2, or 3. So that's telling us which object is going to be spawned, where it's going to be spawned. So we're going to spawn it at that X position. And then as far as its Y position, it'll be 0.05F. I just was trying to make it slightly above the ground. That way there'd be no friction, no collisions. You might not have to do that. It all depends. Like for instance, if your ground doesn't have a collider, then you don't have to worry about that. I just want to explain why it wasn't 0 even. And the F is there because it is a decimal, and you have to use an F to identify it as a decimal. And then 55, that is just putting it beyond the range of the camera. I think the box might have a little bit of clipping that it kind of pops into the scene, so you might have to change that. And again, that's because I have my camera at that position at that angle. You're probably going to have your camera in a different position in a different angle. So the takeaway isn't to memorize this number. The takeaway is that this is putting it just outside of the range of the camera. And like I said, I think that number might have to be slightly bigger. I think the crate kind of blips in a little bit. Okay, so that's the second argument, where it's being instantiated, again, separated by a comma, and then the rotation. Well, this should look very similar to the first one. Again, we're saying all items, so we're using the array, which item, and then we're going to use that rotation. So we're saying spawn this item and apply its own rotation, because you don't necessarily do that. Sometimes you apply a different rotation. We're saying use its default rotation, so whatever rotation it is here as a prefab. And then this just makes it start all over again. Start coroutine spawn timer. So very simple, clean code. Between the two scripts, we've got, what, maybe 10, 11 lines of code? Now, there still needs to be a little bit more when it comes to movement of the player. I wasn't planning on doing another video. If you want, I can. But at that point, it really becomes redundant because that movement is pretty much the same. You're just having, again, you're going to probably use a rigid body, add velocity for a fixed amount of time to have them move one direction or the other, and I already have a full tutorial for that. That part wouldn't change. So let's run it. I think we already ran it at the beginning of the video. I've tried a few attempts to film this and I keep messing up, so I don't remember if I demonstrated it. So there's our rock. There is our fence. Again, a rock, crate. That would be a pickup, a collectible. So not really seeing anything spawn in the middle. There we go. And that's just because you only have 3 lanes. So you got a good chance of having duplicates. In another version of this I was working, actually you can see it right here, the same lane was chosen 4 times. So when you only have 3 lanes, that's going to happen. Now, if you notice there's a little bit of jitter as this gets closer, I believe that is because this is not an executable, because it's still running in the editor. I believe that clears up with the executable. If it does not, I believe one of the things that you can do is you need to change when things are being rendered. So might move this to the late update, I believe. I'd have to check, but if you do have jitter and you are doing this, let me know. And as I've mentioned before, you technically don't even need to use the all-in-one sprite shader. You can actually do this with a texture scroll, and I'll probably event a texture scroll that doesn't require the all-in-one sprite shader. Basically, this just makes it, a checkbox and moving a slider. You can actually do this with coding without the sprite shader. Okay, so I think I answered that question. People wanted to know how to instantiate objects. That demonstrates it. So if you want to say anything else, leave it in the comments field and I'll add that. And then what I'll probably do is if this does go on one or two more videos, I'll probably repost all the videos combined for this series into a single one. That way it separates it from my other endless runner video because I already have a full series about that from, I don't know, like a year ago or so. Okay, so that should about do it. Again, if you like this, please consider liking the video. Please consider subscribing if you haven't. The overwhelming majority of views come from non-subscribers. And please enjoy the rest of your day.